All right, let's talk about one of the biggest ideas in human history. We're talking about the idea that literally knocked our entire world off its pedestal. This is the story of Nicolaus Copernicus and how he completely redrew our map of the universe.
So, that's the big question, isn't it? How on earth did a guy with a super demanding day job, living way out in what was considered a remote corner of the earth, manage to overturn a so-called truth that had been set in stone for 1,400 years? How did he pull off this incredible feat of putting the sun at the center of everything? Well, that's the puzzle we're going to piece together today.
Okay, so first things first. To really get Copernicus, you've got to get the world he was living in. Because this wasn't some quiet, static time. No way. He lived in an age of absolutely massive disruption, where old, comfortable certainties were being challenged left and right.
And what's so wild is when you look at the timeline. In 1492, right when Copernicus was a young man, you have Columbus sailing off and shattering the old maps. Then in 1517, Martin Luther comes along and challenges the ultimate authority of the church. So you see, Copernicus wasn't working in a bubble. His revolution in the stars was happening at the exact same time as this huge wildfire of new ideas was redrawing the world right here on Earth.
You know, every great breakthrough really starts with a problem. And for Copernicus, the problem was this ancient, elegant, but incredibly complicated model of the universe, a model that had been the undisputed champion for nearly a millennium and a half. And this was it, the Ptolemaic system. And honestly, it kind of makes sense, right? The Earth feels stationary, and we can all see the sun, moon, and stars wheeling around us every single day. For centuries, this model was good enough to predict where the planets would be. But to keep it working, they had to add some, let's call them patches. And this is the main villain of our story. It's called the equant. The best way to think of it is as a mathematical cheat. See, the ancients believed that everything in the heavens had to move in perfect circles at a perfect, constant speed. The equant broke that beautiful rule. It was a fudge factor, a little trick that made the math work, but to someone like Copernicus, it just felt wrong. It was messy. And don't just take my word for it. These are his own words right here. For Copernicus, this wasn't just a numbers problem. It was an aesthetic one. He believed the universe should be beautiful and elegant. And Ptolemy's system, with all its fixes and cheats, was anything but.
So who was this guy who got so worked up about a cosmic puzzle? You're probably picturing a professional astronomer, right? Locked away in some tower, staring at the sky 24/7. Well, you'd be wrong. He was actually one of the busiest men in Poland.
Just look at this guy's resume. He was a church official, a doctor, a military commander defending his town, an economist writing about currency reform, and then, way down at the bottom of the list, an amateur astronomer. This was his hobby. The fact that he solved one of the biggest puzzles in human history in his spare time is just, well, it's mind-boggling. So here we have this incredibly smart, incredibly busy guy who is just deeply unsatisfied with this 1,400-year-old machine of the universe. So what does he do? Well, he starts tinkering. He starts taking the whole thing apart to see if maybe, just maybe, he could build something better. And what's crucial to understand is that this wasn't one single eureka moment. It was a very logical, step-by-step process. So, step 1, he hated that messy equant. Step 2, he reads about this cool mathematical trick that lets him swap around a planet's orbits. Step 3, he realizes that when he does this, it magically ties all the planet's orbits to the sun. But that created a new problem, a celestial traffic jam. And that led to step 4, the giant, radical, unthinkable leap. What if you just move the Earth out of the center? The whole problem just disappears. And wow, this slide just shows you the payoff. The old view on the left needed these crazy, complex circles on circles just to explain why planets sometimes look like they're moving backward in the sky. But in Copernicus's new system on the right, it's just a simple illusion. Think about it like this. You're in a car on the highway and you pass a slower car. Let's say that's Mars. For a moment, against the distant trees, that slower car looks like it's going backward. That's all it was, a trick of perspective caused by our own motion. But this elegant solution had a huge consequence. This wasn't just about rearranging the planets on a chart. It fundamentally changed our place in the entire cosmos. For the first time ever, the universe had a real logical structure. With the sun at the center, this beautiful pattern just emerged. The farther a planet was from the sun, the longer it took to go around. It was what Copernicus called a sure harmonious connection. The system finally made perfect sense.
And that was the revolution. Not just a new diagram, but a whole new reality. Copernicus didn't just move some circles around. He demoted our entire world. He made the Earth a planet. And in his quest for that beautiful simplicity, he believed he could model the entire ballet of the planets, as he put it, using just 34 circles. 34! Compare that to the clunky, complicated machinery of the old system. That's the elegance he was looking for all along.
And that kind of leaves us with a final thought, doesn't it? Copernicus challenged a truth that had stood firm for 1,400 years, something everybody thought they could see with their own two eyes. So it really makes you wonder, what's our motionless Earth today? What's the one fundamental fact we all take for granted that's just waiting for someone to come along and show us we've been looking at it all wrong the entire time?